Write down the first three non-zero terms of the Maclaurin series for sine of x and e to the power of x squared. It is given in a data booklet that the Maclaurin series for sine of x is x minus x cubed over 3 factorial plus x to the power of 5 over 5 factorial plus so on. So for sine of x, we can write directly that it is equal to x minus x cubed over 3 factorial, it's 1 times 2 times 3, which is 6, plus x to the power of 5 over 5 factorial, it's 1 times 2 times 3 times 4 times 5, it's 120, plus so on, plus higher powers of x. Series for e to the power of x squared can be found by substituting x squared for x into the series for e to the power of x. It is also given in a data booklet, so it becomes 1 plus x squared plus x squared and squared x to the power of 4 over 2 factorial is 2, so x to the power of 4 over 2 plus so on. The next question, we can find the Maclaurin series for e to the power x squared multiplied by sine of x up to term containing x to the power of 5. It is suggested up to and including a term containing x to the power of 5. So e to the power of x squared multiplied by sine of x can be rewritten as using the previous result. 1 plus x squared plus x to the power of 4 over 2 plus higher powers of x multiplied by x minus x cubed over 6 plus x to the power of 5 over 120 plus higher powers of x. And now we consider this expansion. In general, there are infinitely many terms, but we need terms up to and including a term containing x to the power of 5, and we can get terms up to and including a term containing x to the power of 5 when this one is multiplied by x, when this one is multiplied by negative x cubed over 6 or minus x cubed over 6, when this one is multiplied by this x to the power of 5 over 120, so plus x to the power of 5 over 120. Then when this x squared is multiplied by this x, so plus x cubed, when this x squared is multiplied by this negative x cubed over 6, so minus x to the power of 5 over 6, and when this x to the power of 4 over 2 multiplied by this x plus x to the power of 5 over 2 plus higher powers of x. We can simplify it to get x minus 6 over 6 minus 1 over 6, so plus 5 over 6x cubed, and with x to the power of 5, a common denominator is 120, so 1 minus 20 plus 60, so it's plus 41 over 120 x to the power of 5 plus so on, plus higher powers of x. The next question C, use the result of part B to find this limit. It is equal to limit x plus 5 over 6 x cubed plus 41 over 120 x to the power of 5 plus higher powers of x minus x divided by x cubed. It is equal to, you can see that x cancels, and dividing each term in the numerator and in the denominator by x cubed, we get that it is equal to limit 5 over 6 plus 41 over 120 x squared plus higher powers of x. To be clear, that if you substitute 0 for x, you get that it's 0, so you get 5 over 6 plus 0, so this limit is equal to 5 over 6. And that's all for this question.